Simplifying expressions now. So we're going to try, as best we can, to use some of our properties that we know to make our lives easier. Those properties are the commutative property, which means that we can do the operations in any order. This is only true for multiplication and addition. The associative property, which says you can move parentheses around. Again, only true when we're just adding or just multiplying. The distributive property, which says if I have a number outside of parentheses, I can multiply it to everything in the parentheses. Remember that looks, if I'm drawing arrows, it would look like this, giving the x to the a and the b so that we get a times x plus b times x. And then like terms are terms that have the same variable, specifically raised to the same exponent. We've seen that before. So, simplify. You can brute force these, by the way, but there's a smarter way and there's a harder way. If you want to do it the harder way, have fun. I want to do it the smarter way. So 4 times 9 times 25. All multiplication, so I can do this in any order I want. I don't want to do 4 times 9 because then I'm going to have 36 times 25, which I don't know. On the other hand, I can do 4 times 25 and say, hey, I know that, that's 100. And 100 times 9, well, hey, that's easy too, that's 900. Working smarter, not harder. Same idea with the addition problem over here, 25 plus 48 plus 75. 25 and 75, I know real fast, make 100. And 148 is 148. A lot easier than stacking these up and adding vertically, or doing 25 plus 48, taking the 70 whatever, 3 you get, and adding 75. Looking for intelligent shortcuts. 15 times 103. Now you might be looking at this saying, well, there's no shortcut here, just multiply them. To which I say the answer is 1,545, and I know that because I distributed. Yes, I also did it in my head. Yes, I've been doing this a long time. But here's what I did. 103 is really just 103. I can multiply 15 to both 100 and 3 much easier than I can multiply 15 to 103. 15 times 100 is 1,500. That's easy. Add the two zeros. 15 times 3, I hope we all know, is 45. 1,500 plus 45 is 1,545. It's about working smarter, not harder. You can absolutely write 103 times 15, work it all out, get 1545. I don't care. I'm just trying to save you time. This next guy is kind of a trick in that all I can do is distribute the 3. 3 times x is 3x. 3 times 6 is 18. And I can do nothing else because 3x and 18 are not like terms. They don't both have x, so I cannot combine them. Now down here, 12x plus 3x, I can absolutely combine. They both have just x. So I've got 12 x's and 3 more x's. That means I have 15 x's. Okay. Next problem. I've got x's. I've got y's. And I've got numbers that have no variable. Notice how I'm including the sign that comes before the number with the number so that we know what's positive, what's negative. So now I can look at this and say, okay, the x's are in orange, 3 and 4 make 7 of those. The y's are in green, -2 and 1 of those makes -1 of those. So we just write -y. If you write -1y, I will not mark it wrong, but the 1 is unnecessary. And for numbers, I have +5 and -3, different signs. So 5 minus 3, that is positive 2. So simplified, we've got 7x minus y plus 2. This is the part that every year students dislike. It just says simplify, but it says justify each step with an operation or property, which means everything you do, you have to tell me what let you do it. First thing we have to do here is distribute. We have to take the 2 and give it to the x and the 6. So 2 times x is 2x. 2 times 6 is 12. Distribution, by the way, gets rid of the parentheses. And we haven't touched the 3x. We did that by distribution. Now, technically speaking, I would normally say, yes, you can look at this and say, okay, 2x and 3x are like terms, so just add them. Really, though, we are doing something else in the middle. Because remember, by the order of operations, we are supposed to do everything from left to right in order. So really, even though we do this subconsciously, we do this without even thinking about it, we actually do this next step. We swap around the 3x and the 12. We reorder the problem. And the property that lets me do that is the commutative property. And now, because they're beside each other, I'm allowed to add 2x and 3x to make the 5x. And that is combining like terms. There will be questions like this on the quiz. This is the one time you cannot skip. Okay, it's not the one time. Order of operations is like that too. You may not skip steps on the justify problems. You must make sure, if you're going to combine like terms, that they're actually beside each other. And that's almost always going to be using the commutative property.